How's everyone doing? I'm just getting over strep throat, so I figured I would take advantage of me sitting here and not being able to do much and make a SuperSlicer guide for installing the newest version. So first thing you want to do is, if you're a Patreon, you can go into my G drive and get it. Otherwise, go to GitHub and search for SuperSlicer, or you can search for Super Merrill if you have a hard time finding as SuperSlicer. So Super Merrill is what you want. If it comes up, just click his name and then go to SuperSlicer. You have two options. You can either go to JIT releases and get the most recent release that he's made, or if you want the nightly, you go to JIT actions and look for your OS and grab the most recent one. See, that's Linux, Mac OS, Windows 64, 3 days ago. So that's the most recent one. Now, if you're not signed in, you won't be able to download it. And if you're signed in, you will be able to download the most recent config. Now take this and create a shortcut. Yes, place it on the desktop. Is a shortcut which we can take this target and use this hyphen data dir my OneDrive folder. So what I'm going to do is go to OneDrive, SuperSlicer profiles. So this is where my stuff is. So anything in here, you just right click and click show more options, click properties, and grab this location. And see, what I'm doing now is I'm going to make it so that all my computers use the same profiles instead of having them run off of, instead of having to keep all my profiles identical. Now the idea is you can have one set of profiles that stays the same. Base, quote, then paste, and then unquote. Now, even though this is a brand new SuperSlicer install, and so now what happened, all my profiles that I already had came in. Now you can also do something like, say you're a patron and you have my patron G drive, you can add a shortcut to the G drive and then use that as your shortcut for it. But you can have multiple sets of profiles. So say you have profiles that work great and you don't want to mess with them. So let's copy this, paste it, and now let's make this one default. So now get rid of this switch and open up SuperSlicer. And now this is a full normal install. And then we still have the ability to come back and open up this one. And this has all the profiles that I have saved. I will put a link for the G drive folder, but honestly that's only useful if you're going to be using Trudon. So let's come back here and let's say you're going to be using a printer. So you can either go to a custom, or honestly at this point don't even bother using the wizard, is the way I feel. And you come in here and you start. First thing you do is turn on expert mode. Add a printer. So whatever the name of your printer is, if you're using Clipper, put your IP address. And it should just work automatically. If you're running older versions, you just have to put a random anything character in there. But you don't for this. So now you can save. So now we have our first profile. Unclick simple. That seems to be a new bug, but it's worth it for all the extra features. So if you're going to use firmware retraction, then don't worry about any of these retraction settings. This setting, if you direct drive, I like to reduce this down to 5%. I don't use any of these external stuff. If you're using pressure advance, there's no reason to. All these extra settings, you really have no reason to mess with them. Honestly, the most important things is to make sure you have your G-code flavor set properly. If you're running Clipper and you're not streaming G-code from Octoprint, which obviously you pretty much aren't, you can either get rid of this or severely relax it. This is super important to get rid of. And then firmware retraction is good to turn on. If you want your thumbnails to work, enter these settings. Now the next thing to do is to make sure to set your print height and your bed size to match your printer. If you don't know what your origin is, unless you're a Delta, leave this alone. The Delta origin is most likely at center, but once again, don't mess with that unless you have no choice. Now your Z full step. Ideally, you want this to actually be like a half or quarter step of your resolution. So, depending on your machine, if you don't know what this is, just leave it alone. But you can calculate based off of your rotation distance or your steps. So, say you have a lead screw that is 8 millimeters per turn, a TR8 lead screw, and 200 steps per rotation. That would be 0.04, and then you go to half steps since it's a lead screw, you're not going to probably get quarter steps, so that'd be 0.02. And that's pretty much what you can expect, unless you've upgraded to 0.9 steppers, then that'll cut in half. So if you're on a belted Z like the Trudon or Voron, I would say go to 0.01, because you're never going to get 8th step accuracy. An important thing to make sure you don't forget to do is to have proper start and end code, is the one thing I don't want to forget. So I'm just adding this in. Now let's go to our filament settings. Your extrusion multiplier, you're going to want to figure that out. If you haven't done the extrusion test, you can just use these calibrations with filament flow calibration. But a good thing to start at is around like 0.96, 0.95. A lot of filaments end up to, usually run a little larger and tend to over extrude a little bit. If you're using, if you know your filament's density, fill this out. If you don't. But it's just for calculating the weight of your print. Same thing with all this. Your spool weight, leave to 0 unless you want to use it to be able to weigh the actual spool. Temperatures, I'm going to set it for just a real basic ABS setting. This is just for you to know what's going on. It doesn't actually change anything. Shrinkage is obviously if the filament shrinks, you put to what the size went to. So don't put what the size of the part you want to be. Like if you want the part to be a little bigger and you set this to 101, you'll actually make it a little bit smaller. You put it to what the part ended up. Max volumetric speed, if you're on an E3D hot end, set this to 13. If you're on like a Dragon or a Mosquito, you could probably get away with like 20 or 22. And then if you're on another higher end setup, you could go higher. This is more of like a safety. So like 20 or whatever is a good safe setting for that. Cooling. This can be very important if you're running ABS and stuff like that. You can either run a very low amount of cooling constantly or be very careful about running too much cooling. This is set way too high, in my opinion, to be helpful. And this is set too low to be helpful. So I would, just as a rough guideline, change that to around there. Custom G code. This is where you want to set your pressure advance, since it's usually reliant on what filament you're using, and it's also where you want to set your firmware retraction, because those are the things that all change with your actual print, with your filament. And then even if you need to have a G code offset for like PETG, it needs to be spaced a little bit. So literally, it's best to just turn caps lock on. advance, and then advance equals, and then whatever your value is. If you're direct drive, you know, start really, really low, like on the LGX Lite. You know, believe it or not, my pressure advance is like 0.002 for some filaments, but 0.04 is an okay, you know, start. Always make sure to use underscores instead of spaces when it's in a command. So you set your retraction length. Now let's come to the actual print profile. These slow down the slicing a lot. Reverse on odd and extra perimeters, but reverse on odd really is helpful. This, in my experience, you get way better results by just turning that feature off. I also disable this. It's something you can turn on if you need to. Other than that, all these other defaults are pretty decent. This, usually keep bridges and overhangs, is a decent setting. I'll get into this better on later videos. Also, these printers travel so fast, unless it's a bed slinger, I really recommend doing something more like this. That's pretty much good for this page. Now, this is an important page. Slice resolution used to be as default as 0. You don't want that to be infinite. Same thing, you want this to be old percentages so you can use this profile for different size nozzles if you ever need to. But this you want to be based off of the size of your steps. So once again, let's open up a calculator. And if you have you're using GT2 belt most likely, so it's 2 millimeters per tooth. And if you're using 20 tooth pulleys, basically that's 40 millimeters per rotation. So 40 divided by 200 if you're running 1.8 degree steppers is 0.2. We can expect quarter step accuracy again. So 0.05. So honestly, there's really no reason to go beyond 0.05. But in reality, you don't want it to be jumping back over, and forth. So if we do this again and we start at 40 divided by 200 divided by 8, we get 0.025. And then divided by 16, you get 0.0125. So this doesn't hurt being here, but I'm not really sure how much it gains you. So if you're running 0.9 degree steppers, I would keep it here. Otherwise, can't hurt to bring that up to 0.25. And then if you're at 0.25 for there, the model rounding precision, there's no reason to keep it so excessive. So this can actually help clean up the prints a decent amount. Make sure, obviously, that you're keeping this as a multiple. And then the internal resolution, I prefer to lower this on a better printer. So that's pretty much everything for that. Leave all this alone. Infill, you can start with a rectilinear or like an adaptive cubic. If you're worried about quality, Be careful with rectilinear, it can break apart pretty easily inside. So, triangles or cubic is always safe. Top and bottom, once again, you can get into things like ironing and stuff, but if your printer's tuned pretty well, you should have no reason to mess with any of that stuff. Everything else can be left alone. Skirt and brim can be left alone. Support material. In order to edit these settings, temporarily turn it on. And this is pretty important from what I've found, is Z offset should be from filament, not from plane. And usually I go about 75% of my layer height. And then sawtooth. Two layers and 0.2 for interface spacing. That usually gets you a pretty good starting point. If you need them to be easier to take off, you can either lower this density by increasing this number slightly. You can increase the spacing a little bit, but that doesn't really affect adhesion as much as you would think. Sometimes it can actually make things worse because the filament falls onto it and it loosens everything up. So it's a diminishing returns thing. A little bit of a change can alter the way you want. Like if you need it to be a little stronger, you lower this a little bit weaker, raising it a little bit, but it's not like 0.2 is weaker and 0.3 is a lot weaker. It doesn't work like that. Now speed. This is going to be very reliant on your printer, but first thing is to set the travel speed, where as high as you can pretty much go without skipping steps. And then you can either do all percentages for this, which is a pretty safe way to do things, but and then you just edit just the main speed, or you can manually change everything. The most important thing though, bridge speed should really be a constant. That shouldn't be changing, because that's really just has an optimal speed, and if you lower or speed up your print, it doesn't really matter. This being at 300% can cause issues, so don't really recommend doing that either. So infill speed on solid, once you get more in tune with what you want, you can use all these percentages, but in reality, for this purpose, we're just going to set these manually. So I'm going to show you like ratios that I would use. So if you have that set to 150, then you would set the external a little bit lower. Not much, since we have input shaping, there's no need to. The solid infill can be pretty close to this, and the sparse can be their fastest setting. Just doesn't need to be as intense. And then for top solid, you can come down a little bit. Support speed should be pretty much somewhere in between your two infills. And your support interface should be pretty much somewhere right around where your perimeter speed is, maybe a little bit less. Internal bridges you can leave, overhangs you can leave as a percentage of bridges. Gap fill, you gotta be careful not to go too fast. And then thin walls, once again, you can end up going somewhere around your perimeter speed to your, to a little bit faster. This is the most important part. So say I had a recommended 4,900 in input shaping or something like that. I would then go slightly lower for here, 4,500 here. This I would come back and go as my default. And like say I had 4,500 as my recommended, then I would also make that just to be safe, 4,500. Now solid infill, I would go a little bit higher. Sparse infill, I would do the same. Top solid, I would put probably a little bit lower. Support, you got to be a little careful. So but you're not really worried how it looks. So somewhere in between those values is safe. Same thing with the interface. Bridge acceleration. This is important to be whatever your maximum infill was set to. Internal, not so important. Gap fill, very important because this will shake the printer apart. Thin walls, same thing. Keep it at whatever was recommended or slightly lower. Travel Excel, this one can be the highest one as long as you're not skipping a step. So if you know what your limits are, go crazy. Otherwise, keep it, around the same as what you put the fastest for anything else. So once again, these are all the values. Oh, and first layer, always be really conservative with first layer. And this is also a good speed to start with depending on your machine. And have the modifier there. You can use auto speed, but that's once you know everything's working really well. The default values for this are now a lot better than they used to be. You don't really need to mess with them too much. You can increase these a little bit, or if you want, if you're worried about accurate parts, you make everything like 0.45. Never go at your exact nozzle with, for the actual extrusion amount, unless you're using this value. This side, you can use the exact nozzle amount, and it'll make the actual width of the extrusion larger because you have round extrusions, but technically we're treating it as rectangular extrusions. Bridge lines density, you don't really need to mess with this, but with pressure advance, you could set these just both to 100. Other than that, either use nozzle diameter or keep current flow. And now you made a basic profile.